Hello, welcome back everyone. This is an extra devlog episode that will give a deep dive into the terrain generation of Phos. This video will be divided into two parts. First will be focused on the game assets that control and configure the generators, and the second part I will explain some of the code and the internals of the generator. The map generator is configured by one main asset. This asset contains several properties that determine how the final generated maps will look. The first property controls the size of the map. This is defined in number of chunks. Chunks are 16 by 16 tiles. For this video I'm demonstrating with a small 4x4 map in order to speed up the generation. The second property is the tile mapper. This determines which tile is generated based on the altitude. However, it is not used for the generator. A biome painter is used instead. The next property controls the sea level of the generated map. It's pretty self-explanatory. The generator asset allows me to adjust the size of each tile. While this is something that's technically supported for maps, there are some quirks with changing it. But until I decide to use larger tiles, I'll probably won't work out the kinks. The map generator supports sub-generators, which I call feature generators. I use these to generate specific features onto the map, such as resources and structures. The maps used for Phos are not infinite, and are islands or groups of islands. This is achieved by masking the edges of the map down to 0. This is controlled by the border size and border curve properties. The size determines the distance from the edges and tiles that the border curve is applied. The border curve allows me to customize the shape of the land that gets modified by the border. The border does not simply cap the tile height to a specific value, rather it is a multiplier that forces the tiles downwards, allowing the details to be preserved. Next up is the configuration for the parameters of the simplex noise that is used for generating the height map. I can change the scale of the noise that is sampled to create different types of terrain features. Also change the scale on a per noise layer basis, or as a whole. Each noise layer builds upon the previous layer in order to add more details and refine the shape of the terrain. I use 4 layers. The first is responsible for generating the general shape of the landmass. This is followed by a roughness layer. This helps increase the complexity of the initial shape. The next layer makes the most noticeable change to the terrain, the mountain layer. As the name implies, it generates mountainous structures on the terrain. As it is, it looks pretty good, but I wanted to add more details, so I added another layer that carves slight valleys and grooves into the terrain. These layers combine very nicely to create the terrain in Phos. I may make further improvements to the generator in the future to give more unique terrain across different biomes. Each biome is defined by a specific temperature and moisture combination. The maps in Phos are seeded. The seed is determined by the generator. I have the option to force a specific seed or only force it in the editor. A standalone version uses a random seed. Finally, I have a value that sets the limit on the ratio of tiles that are underwater and above water. If a generated map does not meet this requirement, then a new seed is picked and the map is regenerated. This ensures that a map does not contain mostly water. Now we'll take a look at the code responsible for generating the map. First we'll walk through the generator code. The generation happens in 4 phases, as hinted before. The first phase is the generation of the height map. The height map is generated by blending all the noise layers. The map border is also applied in this phase. After the height map is generated, the land and sea ratio is checked. If it passes, which happens most of the time, we move on to the next phase. The temperature map is generated by determining an equator point, which will be the warmest point on the map, and then the temperature is lowered as the distance increases from that point. The temperature value is also blended with the height map, allowing the terrain to influence the temperature. In Phase 3, the moisture map is generated. This is done by sampling the noise filters again at a different scale. The sampled noise is then remapped, and that's the final moisture map. Finally, all the values generated by the previous 3 phases are used to assign the tiles to the map. The biome painter uses the moisture and temperature to determine a biome. Then the altitude is used to determine a tile within that biome. At this point, the map generation is technically complete. Feature generators can now be applied to the map. I will only go into one of the feature generators because the rest of them are pretty simple. The resource generator uses a cellular automata to distribute resources onto the map. I found that this gives a lot more control than using noise. I'm using a generator that was designed to generate caves, but I made some adjustments to make it work for resource generation. It creates nice clumps of resources that are distributed across the map. That concludes my deep dive into Phos's terrain generation. If you have any questions, feel free to ask in the comments or in the Discord server. Leave a like to show your support and subscribe for new videos. And don't forget the wishlist on Steam.